Alright guys, here we go with 11.2. We just talked about what are logarithm functions. Now in this lesson we're going to focus on the graph of these functions. So the first part of this exercise is that we're going to consider two functions. We're going to consider y is equal to the log of base 3 of x, and the inverse, which we saw was an exponential function, y is equal to 3 to the x power. So the first thing I want to do is put this in the calculator. Once you put this in the calculator on your graph, you're going to have plot these points. So it's going to be, this is actually going to be 1 over 9, 1 over 3, 1, 3, and 9. Now, because these are inverses of each other, remember what happens if they're inverses. We know that they switch. So my x and y switches. So in this case, my x is going to be 1 over 9, and then my y, my output, is going to be negative 2. And I'm going to go ahead and fill up this table using my function. It's negative 1, 0, 1, and 2. Now graphically, what does it look like? So I want to plot these. At 0 it's 1, and I'm just going to be at 1 it's 3, at 2 it's 9, so that will be somewhere here. At negative 1 it is 1/3, which is close to the bottom, and then here. So this will be, your graph will look way better than mine, but this will be our graph of y equals 3 to the x. What will this graph looks like? So at 1/9 it will be negative 2, which is right here. 1/3 it's negative 1. At 1 it's 0. At 3 it's positive 1. At 9 it's 2. So you'll have a graph that looks something. Oh, let's redraw that line. Whoops. See, you're going to be better at this. Passing through all the points. There you go. And then don't forget to label. This is actually the log of base 3 of x. Now it says graph this, which is what we just did. C said state the domain of these functions, the domain and range. So domain, as we remember, is my x, and range is my y. So the domain of this function, the first one, which is in black, what do you notice about the domain? Notice when I graph this, my arrows are going up, meaning this graph goes on and on forever, and so does it. It goes on and on forever. So my domain is going to be, what did it say? No, so I can use anything. So it can be from negative infinity to positive infinity. My range now, my range is my y value, and if you look at this first graph, it's never going to pass the y equals 0. It will go very, very close, but it will never, ever pass, go below the x-axis. So my range is going to be from 0 to infinity. Actually, this is not included because it will not touch 0. It will only go really close to it. Now let's take a look at what's happening with the inverse, which is the log function. So again, the x value, remember it switches, so the x value for my domain, it gets closer and closer to 0, but it will never touch 0. So my domain will be 0 to infinity. It'll get this is my 0 on the x. So it'll always get close to this line but never touches it, and this will keep going forever. Now what about the range? So the range is the same thing, x and y. The arrow is always going down, and it will be always increasing. So that will be the negative infinity to a positive infinity. Notice they are kind of opposite of each other, which is what it should happen. Now exercise 2 says for you to go ahead and sketch this function, which is the log of base 10 to the x power, and then write the domain and read. So I want you to pause the video and try to do this on your own. Remember to set the window from +2 to -2, and then your x will be from 0 to 10. So go ahead, pause the video, and graph this. Hey, now you got a chance to try that. You should have, first of all, a better looking graph than mine, but you should be able to see that the domain goes really close to 0, but it never touches or crosses it, meaning never goes into negatives. And the range is, again, from -infinity to +infinity. And this will happen all the time for a log functions. Moving along, which of the following graph would describe this situation? Now, this is where you go into your calculator and you graph all of this. Remember how to get the log of base 3. So for example, let me put my calculator up really quick here. So I am at graph and I want to graph the first one. It says what I hit, hey, there you go. Remember, choose the log. I want to enter base 3. In the parentheses is x plus 2. Notice the -1 is outside. Ooh, I'm not finished. -1 is outside, and then you hit enter. So you're gonna, if you look at this graph and look at the graph that's given to you, you will automatically see that's not the answer. So you're gonna do this for all of them, and eventually you're gonna find choice 3. And again, the calculator does everything for you. Just know how to enter this. We have 2 more examples to go. It says, determine the domain of a function y is equal to log of base 2 of 3x minus 4. State your answer in set builder notation. So remember when we did, and on a side note, when we did find the domain of a function of a square root of x plus 4, you would take everything under your radical and you would make it greater than or equal to 0, and then you would solve. So for example, here my domain would be everything that x such that x is greater than or equal to -4. Now with log functions, we take what's in parentheses, which is the 3x minus 4, and we make it greater than 0. Remember, this time it's not equal to, because we saw in the previous example, our domain is always going to be close to 0, never touches it, so it will never be equal to 0. And then I would solve this as regularly. 3x is greater than 4, x would be greater than or equal to 4 over 3. And it's asking for set builder, so my final answer will be x such that x is greater than 4 over 3 with my little squiggly brackets. Alright, so they're very similar. It's just because square root function, the 0 is included. Here, our 0 is not included. Now, what about number 5? If we have the same thing, it says solve the quadratic function. I want to find the domain. So in order to find the domain, I need to go ahead and solve this quadratic function. So here, it's x squared minus 3x minus 10 has to be greater than or 0. My a is 1, my b is -3, and my c is -10. So -10 on top, -3. These numbers are -5 and +2. So this is actually going to be x minus 5 and x plus 2 is greater than 0. So now what do we need to do? If we solve this, I get x is equal to 5 or x is equal to -2. Now how do I know how to put these in the calculator? So you have 2 options. You can graph this and then something special happen at these points, or we can go ahead and test some numbers. So again, what I did from this step to this step, so all I did was say x minus 5 is equal to 0, x plus 2 is equal to 0, and I got these answers. So I need to do some tests. So x has to be equal to -2, and then x has to be at 5. So how do I know what to do here? Now go to calculator, delete whatever you have, and then I'm going to go to graph. I want to enter this function. I am going to enter, actually it's a no, just regular log of x squared minus 3x minus 10. Enter. Look at what's happening here. These were the answer. We had -2 and +5. So if you notice, from -2 is going everything that's less, because my graph is on the left, and then at +5 is the graph is going to the right, and when the graph is going to the right, it's increasing. So when I write my notation, my final notation would be x such that x would be less than -2 because my graph is going, or x has to be greater than 5. So again, this is my integral notation. It says, do I need to set up the inequality and give the domain, solve the quadratic inequality, and that's it. So again, on a number line, it will show you this is 0, this is -2, that's 2, that's 4, and let's just say by chance this is 6. So it just means that your graph will be going this way, and if it's here, it goes that way, which is exactly what's happening in this picture. So at -2, my diagram goes to the left, and at +5, it goes to the right. Alrighty, that's it for today's lesson. Go ahead and do those practice problems. Good luck!